Hello everyone, in this video let's discuss about the JK flip-flop. If you are new to our channel, please subscribe for more engineering related topics. So to get full marks in JK flip-flop, we will follow the 5 steps. So first step will be drawing the block diagram. First step is drawing block diagram. Next, second step. So while writing the second step, you must take the reference of the first step, that is block diagram. What is second step? Second, circuit diagram. Second step is circuit diagram. Next, third step. While writing third step, take the reference of second step. Third step is truth table. Next, fourth step. Fourth step is characteristics table. While writing characteristic table, take the reference of previous step, that is truth table. Next, fifth step is excitation table. While writing excitation table, take the reference of characteristics table. Now let's start with block diagram. So we know that in flip-flop there will be only two outputs. So that will be Q and Q bar. You can use A bar, B bar, like that also. So what Q bar represents is one output is the complement of other. That is, if you give 0 as the if you get 0 as output here, the other output will be its complement. That is 1. If you get 1 as the output, then the another output will be equal to 0. That is complement of the other output. So you cannot get the same output values. Now, while designing the input side, we also know that every flip-flop, that is all flip-flop, D flip-flop, T flip-flop, all will have one common input, that is clock. So the clock will be common input for every flip-flop. Now another two inputs are J and K. Now we completed the block diagram of JK flip-flop. Next step is using this block diagram, draw the circuit diagram. Circuit diagram. To draw the circuit diagram, we can use NAND gate or NOR gates. So I am using NAND gate. Let's draw the latch first. After drawing the latch, then we can draw the flip-flop. So how to draw latch? You can use NAND gate or NOR gate. Output will be Q bar. Output of this one will be as the input to this one, and output of this one will act as input to this one. So we draw the latch. To draw the flip-flop, we will add another NAND gates. Now we have the common input, that is clock. The clock value will always be equal to 1. Clock value will always be equal to 1. It will not change. Next we have another two inputs, that is J. Another one is K. Now we completed the circuit diagram. Now let's go for the third step, that is truth table. While writing truth table, we must take the reference of the second step, that is circuit diagram. What are the inputs? J, clock and K. Since clock value will always be equal to 1, let's consider only J and K. J and K. So what will be the output? The present state output or the new state output will be the output. New state output. Qn plus 1 means new state output. Since we have two combination, that is two inputs, what will be their combinations? 0 0, 0 1, 1 0 and 1 1. So I will share a short trick. If both J and K value will be equal to 0, write Qn. What is Qn? Qn is the previous state output. Qn is previous state output. Next, if both J and K value are equal to 1, then the output will be complement of the previous state output. If both the inputs, that is J and K value, will be equal to 1, then the output will be previous state outputs complement, that is Qn bar. Now, if J value is equal to 0, K value is equal to 0, write J value as output. If J value is equal to 1 and K value is equal to 0, write the J value. So, if same inputs, that is 0, Qn. If 1, Qn bar. If j value is equal to 0, output will be 0. J value is equal to 1, output will be 1. Simple. Next, using this truth table, we must draw the characteristics table. So the fourth step is characteristics table. So to draw the characteristic table, let's take the inputs. What will be the inputs? J, K and Qn will be acting as the inputs. So we have three inputs. What is Qn? Qn is the previous state output. Next, the output will be Qn plus 1. That is new state output will act as the output of characteristic table. Now, since we have three inputs, what will be their combination? 0, 0, 0, 0, 1, 1, 1, 1. 0, 0, 1, 1. 0, 0, 1, 1. 0, 1, 0, 1, 0, 1, 0, 1. Now we wrote all the possible combination of the three inputs. Now let's write the Qn plus 1. So first, when j value is equal to 0 and k value is equal to 0. Here j value is equal to 0, k value is equal to 0. So in truth table what we wrote? Qn, output will be Qn, that is previous state output. So here previous state output is 0, here previous state output is 1. Next, when j value is equal to 0 and k value is equal to 1, j value is equal to 0 and k value is equal to 1, what we will take? J value, that is 0, 0, 0. When j value is equal to 1, k value is equal to 0, we will take the j value, that is 1, 1. When j value is equal to 1 and k value is equal to 1, here both j value 1, k value 1, j value 1, k value 1. What we will do? Complement of the previous state output. So here 0 is there, we will write 1. Here 1 is there, we will write 0. Simple. Now let's write the characteristic equation using this characteristic table. To write the characteristic equation, we will use the K map because we are having three inputs. Let us consider J, K, Q, N. So J will have 0, 1, two inputs. Here two inputs are there. So 0, 0, 0, 1, 1, 0 and 1, 1. So first we will write 0, 1. After that we will write 1, 0 right here. Then 1, 1 we will write here. You should be knowing how to write K maps. So K maps video link are provided in the description. You can watch. So now this will be 0. Let's index them 0, 1, 2, 3 because we shifted here and then came here. So 4, 5, 6, 7. So 0 to 7 means 8. So now number. So where 1 is there, you see 0, 1. So at the 1's place 1 is there. Next 2, 3, 4 at 4th place. Next 5th place. Next 6th place. So while grouping the K maps, we must be knowing that we can group them using 2 powers. That is 2 power 1, that is 2, 2 power 2, 4, 2 power 3, 8, like that. 2, 4, 8, 16, like that we can group. So now let's group with 2 members each. These two and these two will be grouped. So how can we write the equation? So see, while considering these two, in left hand side j value is varying. So once it is for this one value is 0, for this one value is 1. So the j value is varying, we will not write. So what is the value of 1, 1 for k? Now for 1, 1 for both the k and qn value is 0 and 1. 0 and 1. So we will write k, qn, but 0. What is the value of 0? K. So k bar qn plus, we will write this equation, this one and this one. So what will it be? 1 is constant. For this one also j value is 1. For this one also j value is 1. So j. Next if we consider for this one k is 0, qn is 0. For this one k is 1, qn is 0. What is constant? Qn. So here also qn is 0, here also qn is 0. So we will write qn. So 0 is the value of qn. So we will write qn bar. So the short trick to write I have discussed in the K maps video. I will provide the link in the description. You can watch it. So what will be the equation for the JK flip-flop characteristic equation? k bar qn plus j qn bar. Now let's write the excitation table using this characteristic table. In the excitation table, what will be their inputs? Fifth one is excitation table. In excitation table, we will use the previous state output and new state output or present state output as the inputs. Next, what will be their output? J and K will be their output. Present state and new state output will act as the inputs and J and K will act as the output. Now see, since we have two inputs, what will be the combination? 0 0 0 1 1 0 and 1 1. See, when qn value is 0 and qn plus 1 value is 0 in characteristics table. Qn value is 0, qn plus 1 is 0. Another qn is 0, qn plus 1 is 0. So that's all. So see the j and k value. J value is 0 here. Here also j value is 0. So we can write j value as 0. Next, here the k value is 0, but here the k value is 1. That is, it is varying. So we will not write. Not defined. Next, qn is 0, qn plus 1 is 1. Qn is 0, qn plus 1 is 1. Qn is 0, qn plus 1 is 1. So now we are considering this. So what is j value? J value is 1. Here also j value is 1. So right. Here k value is 0. Here k value is 1. That is, k value is varying. We will not write. Next, third one is 1 0. So 1 0. Here 1 0 is there and here 1 0 is there. Qn value is 1. Qn plus 1 value is 0. So here 1 0 1 0. What is j value here? 0. Here 1. So the j value is varying. We will not write. What is the k value? Here k value is 1. Here k value is 1. So we will write 1. Because it is not varying. Next, qn value 1. Qn plus 1 value 1. So 1 1 and 1 1. What will be the j value? Here it is 0. Here it is 1. It is varying. We will not write. Here k value is 0. Here k value is 0. So the same zeros are there. We will write 0. So I hope you understood the concept of JK flip-flop. If you have any doubt, please comment below. If you like the video, please subscribe and support for more engineering related topics. Thank you.